Welcome you all. Myself Nagarajan, Assistant Professor in Department of ECE at Rohini College of Engineering and Technology. In this video, let us see the optical communication fifth topic, that is a mode analysis for optical propagation through fibers. Let us see the optical propagation through fibers mode analysis. After completion of this video, the student will be able to understand the accepting angle, acceptance cone, numerical aperture. So let us see one by one. So the light rays are traveled in a fiber optic. It has a cladding and it is a core, cladding and core. So to understand the general nature of light wave propagation in fiber optic, we first consider the construction of a optical fiber. So in the optical fiber, it has a two part. One is a cladding and another one is a core. So innermost of in the glass core of very thin diameter with refractive index of N1. The glass core is surrounded by a cladding material with a slight lower refractive index N2. The light wave can propagate along such a optical fiber. A single mode propagation is illustrated in figure along with the standard size of a fiber. The single mode fibers are capable of carrying only one signal of a specific wavelength. In multimode propagation, the light propagates along the fiber in a zigzag fashion, provided it can undergo total internal reflection at the core cladding boundaries. The total internal reflection at the fiber wall can occur only if two conditions are satisfied. First condition, the index of refraction of glass fiber must be slightly greater than the index of refraction of material surrounding the fiber. If refractive index of glass fiber is equal to N1 and the refractive index of cladding is considered as a N2. When N1 is greater than, and second condition, the angle of incident pi 1 of light ray must be greater than the critical angle pi 2. A light beam is focused at the one end of a cable. The light enters the fibers at different angles. Figure shows the condition exists at the launching end of a fiber optic. The light source is surrounded by air and the refractive index of air is N0 is equal to 1. Let us the incident ray makes the angle pi 0 with the fiber axis. The ray enters into the glass fiber at point P, making a refractive angle pi 1 to the fiber axis. The ray is then propagated diagonally down the core and reflect from the core wall at a point Q. When the light ray reflects off the inner surface, the angle of incidence is equal to the angle of reflection, which is greater than the critical angle. So this is a figure. So the ray propagation of a total internal reflection. So fiber axis, external angle of the incident waves are traveled in the zigzag manner. So two sides we having a cladding and inner side is we are considered as a core. So order for a ray of light to propagate down the cable, it must strike the core cladding interface at an angle that is greater than critical angle pi. Let us see the accepting angle. Applying a similar to external incidence angle, N0 sin pi 0 is equal to N1 sin pi 1, but pi 1 is equal to 90 degree minus pi c. Sin pi 1 is equal to sin pi 0, 90 degree minus pi c is equal to cos pi c. Substituting sin pi in the above equation. So N0 sin pi is equal to N1 cos pi c. Sin pi 0 is equal to N1 divided by N0 cos pi c. Applying Pythagoras theorem to triangle PQR. So cos pi is equal to root of N1 square minus N2 square divided by N1. Sin pi 0 is equal to N1 divided by N0 root of N1 square divided minus N2 square divided by N1. So angle value is a pi 0 is equal to sin inverse of root of N1 square minus N2 square divided by N0. The maximum value of external incident angle for which light will propagate in the fiber pi 0 is equal to sin inverse of root of N1 square minus N2 square divided by N0. When the light rays enter the fiber from an air medium n naught is equal to 1, then above equation is reduced. Acceptance cone. Next one is the acceptance cone. Rotating the acceptance angles phi naught around the fiber axis, a cone shaped pattern is obtained. It is called as the acceptance cone of the fiber input. The following figure shows the information acceptance cone of a fiber cable. The cone of acceptance is the angle within which the light is accepted into the core, and it is be able to travel along the fiber. The launching of light wave becomes easier for large acceptance cone. The angle is measured from the axis of the positive cone, so the total angle of convergence is actually twice the starting. So let us see the numerical aperture. The numerical aperture of a fiber is a figure of merit which represents its light gathering capability. Larger than the numerical aperture, the greater the amount of light accepted by fiber. The acceptance angle also determines how much light is able to be enter the fiber, and hence there is a relation between the numerical aperture and the cone of acceptance. Numerical aperture Na is equal to sin phi naught. So Na is equal to root of n1 square minus n2 square divided by n0. N0 is equal to 1 means that is the Na is equal to root of n1 square minus n2 square. So numerical aperture is a, when we consider the core and cladding means it is a n square core minus n cladding square. Hence acceptance angle sin inverse of numerical aperture. By the formula of numerical aperture, note that the numerical aperture is effectively depend only on the refractive index of core cladding material. Na is not a function of fiber diameter. So index difference and the numerical aperture are related to the core and cladding indices. So Na is equal to root of n1 square minus n2 square. So del is equal to Na square divided by 2 n1 square. So Na is equal to n1 square minus n2 square whole power 1 by 2. So let us see the review questions. What is the numerical aperture of an optical fiber? Deduce an expression for the same. Describe the ray theory behind the optical fiber communication by the total internal reflection. State the and in it. Draw the neat diagram and explain the ray theory behind the optical fiber communication with a special mention about the total internal reflection, acceptance angle and numerical aperture. Dear student, I hope that all of you understood about the this video. Thank you.